Welcome. Let's take a look at applying Newton's method to solve a problem, in this case to approximate the real zeros of a function using a spreadsheet. So when we're using a spreadsheet, we'll want to calculate a variety of quantities. So here is a spreadsheet that I've set up that has columns representing all of the quantities I need to know in order to implement Newton's method. In the first column where we have n, that's going to keep track of the number of iterations that we have completed. Xn is the approximation to the real value that we're looking for. We'll need the function value at this point. We'll need the derivative of the function at xn. And then we need the ratio of f at xn over f prime at xn. And then to find our next iterate, our next successive approximation, we take our original approximation on this iteration and subtract from it this ratio. And what we want to do is see if those two values, if this new value and this previous value, this xn, see how close they are to check to see if we are converging onto a solution. So this is the absolute value of the difference between the two. So as we get closer and closer to the solution we are looking for, the values in this column should get closer and closer to 0, telling us that we are converging upon a solution. So let's go back to our original problem and find its derivative and get ready to implement Newton's method using this spreadsheet. So in this particular instance, we're looking for the real zeros of f of x equals 2x squared minus 3 that lie close to x1. So for Newton's method, we need the function. And so what we're trying to do here is approximate the real zeros of this function f of x equals 2x squared minus 3 that lie closest to x equals 1, and we want our approximation to be accurate to basically the 4th decimal place. So recall that we need to have a situation, or we only apply Newton's method in the instance where we have some kind of function equal to 0. And notice that conveniently we're asked for the real zeros of this function. And so in this particular case, we are looking for where does 2x squared minus 3 equal 0. That's what we mean by the zeros of a function. And so in applying Newton's method, the function we were given is the function that we will use. So we will be applying Newton's method to the function 2x squared minus 3. Recall that as part of Newton's method, we need the derivative of this function. So f prime of x equals derivative of 2x squared minus 3 is 4x. And we need our first approximation. Now, probably the easiest thing to do, maybe even the most obvious thing to do, is we want our solution to be close to x equals 1. So we will let our first approximation simply be 1. So with those details in mind, we're ready to put this into a spreadsheet. Now, what's nice about a spreadsheet is if you have formulas that you want to repeat over and over again, it's very simple to do by copy and pasting rows or cells and repeating that formula. So let's go ahead and see how this might play out with this particular situation. So we know that we wanted our first iteration to be 1. So I'm going to click on this cell here. Notice it's in column C, row 6, so C6, I'm going to enter 1 because that's where we want to start. That's going to be our first iteration. Now, we said that the function itself was 2x squared minus 3. Now, we could type in, and notice up here, I'm typing in this bar, and notice there's this f of x. We're going to insert a function here. We could say this equals, we want to evaluate our function at 1. I could just type in 2 times 1 squared minus 3. And my answer is -1. So the function value there is -1. But it's not easily repeatable because notice that for if I copy and paste this, I'm getting the same value each time. And we really want to let the spreadsheet do the algebra for us. So what we want to do is say this is equal to, and again, watch up here in the function bar. Our function was 2x squared minus 3. So we're going to go 2 times, now my x is in location C6. So we're going to do 2 times C6. Notice that it has highlighted that cell, telling me that that's the value it's going to use. I'm going to square that, and then I'm going to subtract 3. I'm going to hit enter, and notice that it's displaying the value of -1 in the spreadsheet, but up here in the function bar, I can see the function that I inserted. So that looks good. Here we're going to do a similar thing, but we're going to work with our derivative. Our derivative was 4x. So we want this to be equal to, now come up here, watch what's going on in the function bar, 4 times our x value, and our x value was way over here in C6. So we're going to have 4 times C6. And again, we can see it highlighting that value it's going to pull in, and we end up with a 4. Continuing on, the header of this particular column tells me what I want to do. I want this to be equal to the function value over its derivative. Well, the function value is here in location column D, row 6. So we want D6 divided by the derivative, so E6. So notice it lights up both of those, and they are color tied together in color. And we're going to hit enter. That gives me the ratio, and then in this cell we're ready to find our new next iterate, our new next approximation. Notice we want x in, that's over here in C6. So C6 minus what we have here in this last column, f over f prime, both of those evaluated at xn. So C6 minus F6, and we get 1.25. Now this is our next iteration. So this is the value we want to start our second iteration with. So we're going to, this is located in G6. So on the second row, we're going to enter G6. So equals G6. It's going to pull that value in. Now, we want to know how far apart these iterates are, because the closer and closer they get to 0, the closer and closer they get, that difference is going to get closer and closer to 0. And we'll know that we're converging on the solution. So in this last column, in the first row, we want this to equal the absolute value. Now, spreadsheets have an abbreviation for absolute value. It's ABS. And we want the absolute value of the difference here. xn plus 1 is g6 minus xn, which was c6. So we're taking the absolute value of the difference between 1.25 and 1. And so we're going to get, our iterates are about 1/4 away. So we're going to start the new row with this 1.25 that we found on the previous row. Now here's the power of the spreadsheet. I'm going to highlight all of those columns. I'm going to come up here and I'm going to copy. You can hit Control-C or you can use the menu. I'm going to hit copy and I'm going to move down one row and then I'm going to paste the formulas in. And now what I want you to notice is that, for example, in the D column, in the first row, it's 2 times c6 squared minus 3. But in the second row, we have 2 times c7 squared minus 3. So Excel or the spreadsheet automatically adjusted and referenced appropriate values. If you want to see the functions that are in each cell, that is possible. You can come over here to Formulas, and if you click on this Show Formulas, it will show you the formulas that exist in each cell. I'm going to go ahead and turn that off so we can just see the function values. At this point, I've got 2 complete rows, and notice that while the difference between our successive iterates, the difference between 1.25 and 1.225, this difference is getting smaller, so our successive iterates are getting closer, but we're still not quite close enough. So what I'm going to do is I'm going to take this entire row, I'm going to come up and I'm going to copy it, and then I'm going to paste the function into the next row. And what we see here is that we've gone from an approximation of 1.225 to an approximation of 1.2247, 44, and so forth. And notice the difference between those two successive approximations is getting smaller. We are now nearly within the level of accuracy we were seeking. Keep in mind that we were wanting to be accurate within 0.0001, but we are not quite there. So we need to do another iteration. So again, I'm going to come highlight these entries, these cells. I'm going to come up and copy, and I'm going to paste the formulas in. Oh, and look what we have here. So we have, of course, our result from the previous iteration, our 1.224744898, and of course there's more decimal places there. But what we're interested in here is compare the two iterates. So our previous iteration came up with 1.224744898. Notice that our new iterate is 1.2247448. So notice we are now accurate to 7 decimal places. That's very accurate. That's certainly within the realm of accuracy we were after. Notice over here that the difference between the two iterates is very small. If you're not familiar with this notation, this is 2.65 and so forth times 10 to the negative 8th power. So that is quite small. So it looks like our approximation here should be 1.224744871. This is an approximation of the zero of our original function. F of x equals 2x squared minus 3, and it is accurate to the nearest 0.0001 place. I hope you find this helpful.